Hello friends, this video on dual nature of radiation and matter part 1 is brought to you by examfear.com. No more fear from exam. Topics to be covered in this lesson are history of electron emission, history of photoelectric effect, experimental study of photoelectric effect and wave nature of light, Einstein's photoelectric equation, particle nature of light, and wave nature of matter, which would include de Broglie's hypothesis, Heisenberg's uncertainty principle, and Davison and Germer experiment. So what do you think we are going to study in this lesson? As the name of the lesson says, dual nature of radiation and matter. So in our last few lessons, we were talking about radiation, we were talking about electromagnetic waves, we were talking about light, wave nature of light, ray optics, wave optics, and things like that. So here we are going to talk about the dual nature of radiation. That means here we are going to discuss about that whether a radiation has wave-like properties or it has particle-like properties or it has both. So that is the agenda of this lesson. We will talk about that. However, by this time, so many principles came up, right? Maxwell's electromagnetic theory came up, which successfully could prove that radiation is of wave nature. It told that they are nothing but electromagnetic waves, right? Mutually perpendicular electric and magnetic fields give rise to electromagnetic waves. And he also told that the visible light which we see around us is nothing but an electromagnetic wave. After that came Huygens principle, which again emphasized on the wave nature of light. Huygens principle kind of proved wrong the Newton's corpuscular theory, because Newton told that light is of particle nature. So Huygens was successfully able to prove him wrong. And after that came certain experiments like Young's double slit experiment, which actually displayed the phenomenon of interference, the diffraction pattern produced by the light waves, the phenomenon of polarization. All these phenomena and all these principles were able to successfully prove the wave nature of light. They all told that light is of wave nature and it is not of particle nature. So now the question is, if light is of wave nature, then any phenomenon which takes place related to light, we should be able to explain that phenomenon in terms of wave nature of light, right? Because how the particle nature of light was proved false? Because the interference phenomenon which was observed in Young's double slit experiment, the particle nature of light could not prove that experiment, right? So that is why people told that, okay, that means light is not of particle nature. So now in this lesson, we will talk about certain phenomena which take place and which were not being able to answer, which could not be explained by wave nature of light. So the wave theory could not explain certain phenomena. So as a result, the particle theory bounced back. So the particle theory of light came back again. But this time, the particle theory came with a bang. It is not that light is only particle in nature or wave in nature. It has got dual character. Sometimes it behaves like a particle, sometimes it behaves like a wave. However, it sounds little strange as of now, but as we go ahead in the lesson, we will see that how the radiation, here we are not only talking about light, we are talking about any radiation, right? Because light is also nothing but an electromagnetic radiation. Okay, so here in this lesson we will talk about the dual nature of radiation and also the dual nature of matter. So that means when we reach the end of this lesson, we will say that every radiation has dual nature. That means every radiation can behave as a particle as well as a wave. Similarly, we will also say that matter also has dual nature. That means matter can also behave as a particle as well as wave. Right now, it's really strange, or it is really hard to believe that these statements are true. But when we reach towards the end of the lesson, then you will also agree with me. So now,
Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.